All right, hi guys, this is Mrs. Selectman. I wasn't able to be here unexpectedly today, so we're going to do the first lesson of our first concept unit on video this way. And the first thing you'll notice is that the unit is called proportional relationships. So this actually relates to the second and third focus areas that you are getting into right now on unit rates and on proportional relationships. I know this date here says last year. I forgot to fix it on there, but this definitely is for this year. And there's some information on the front that might be a good thing for you to come back and look at as we get into this and see if it makes sense as you do some more lessons. So we are going to flip to page 1. And this is what page 1 looks like in here. So at this point, I'm going to have you put all of your pencils down. Make sure that you don't have anything in your hand to write with, because for a couple of these pages, we aren't going to go ahead and do what we can figure out how to do on our own. There's a couple of them where the first time we are going to do some talking about it first. So for this whole unit, I'm going to ask you not to go ahead, even if you think you know how to do it, because with these concept units, a lot of the deeper things that we talk about come from talking first and not just doing. So we'll have time to actually do the math, but we also are going to have some discussions about it first. So let's look at this first problem. This one on page 1 says, feeding a crowd. And the question here, feeding a crowd, number 1 says, a recipe says that 2 cups of dry rice will serve 6 people. Complete the table as you answer the questions. Be prepared to explain your reasoning. There's a table, and it asks about how many people 10 cups of rice will serve, and how many cups of rice are needed to serve 45 different people. Lots of numbers here. There's a similar type question on number 2. What I'm going to have you do before you do any math with this is I am going to have you with your shoulder partner. So that's the person who is sitting directly next to you. Your shoulders are near each other. You guys are going to have a conversation for 30 seconds to a minute talking about what strategy you would use to fill in the table blanks and answer these types of questions. And if you come up with the same strategy that you would both use, I'd like you to try and come up with a second one that might work as well. So we're looking for multiple different ways to get answers to these questions here. We're not answering them yet, we're just talking about the strategy. And if you don't have a shoulder partner, if you're a table group of 3, then all 3 of you can talk about this. So right now your teacher is going to set a timer for 1 minute, and you're going to have that discussion. No picking up pencils yet. After 1 minute, we'll tell you what to do. Go. All right, so you guys just had a discussion about how to do this. At this point, we're going to set a timer for 5 minutes, let's say, and you and your shoulder partner can both start doing the work for this whole page. So you're going to do as much as you can on the whole page 1, not moving ahead yet, but page 1. And when you're done, if there's still time, you and your shoulder partner can check your work together and make sure you've got the same answers, even if you used a different method. So a 5-minute timer starting now. All right. So whatever you've gotten done at this point is awesome. We are going to have you pause in working on your own, and we're going to talk about this together a little bit and see what different strategies you guys came up with to be able to answer these questions. And I'm going to point out a couple of things that even if you knew the answers really quickly, now we're going to take this and say, okay, what does this have to do with some other math concepts that we are just going to learn? So even if you felt like, oh, I could do this quickly, I figured out the answers, now we're going to take that and we're going to think a little bit deeper about what these things mean. So 2 cups of rice fed 6 people right here. 3 cups of rice, 9 people. As you were looking at this, when you were trying to find kind of a relationship between these, was this a relationship where you could just add something to 2 cups of rice to get the number of people? Could I say, hey, 2 plus 4 is 6, so that must be the relationship? Is that the same thing here? Is 3 plus 4 9? No. So it's not a relationship where we can just add things together. What about the relationship here in this column? To go from 2 cups of rice to 3 cups of rice and 6 people to 9 people, can I add anything there? 2 plus 1 is 3. Is 6 plus 1 9? No. So there's no relationship where we can use addition for this. But the numbers are getting bigger, so the only possibility we have if we're not adding then is probably going to be multiplying. Is it the same multiplication relationship? 2 times what is 6? 2 times 3. If you didn't put that there, I suspect you didn't. Can you write that in right here? 2 times 3 is 6. Is 3 times 3 9? Yeah, so to get from cups of rice to number of people, we multiply by 3. Go ahead and add that in. All right, so we would expect that this one then, if you've got 10 cups of rice, you're going to multiply by 3 to get the number of people, and now you'll have 30. So I'm hoping you had 30 in there as an answer. Now this one, we don't know the cups of rice, but we know whatever that is, times 3 is going to give us 45 people. So can we work backwards? What times 3 is 45? That one is going to be 15. So maybe you did multiplication. Maybe did anybody think about this as backwards to begin with? And did you do 6 divided by 3 gets you 2 right here? 9 divided by 3 gets you 3? Yeah. So you could do a multiplication or a division relationship. This right here is going to be really important because the number that you multiplied by, I'm going to have you put an arrow right here. That number means something in this question. This is actually going to be a vocabulary word that we need to know. That number tells us how many people we can feed for each cup of rice. It tells us the people per cup. So this number we're multiplying by, it's called a unit rate. The unit rate, it's how many people per 1 cup, people per cup of rice. So when we're multiplying by our unit rate, the people per cup, we know how many cups we start with. We're going to end up with how many people we get to feed total. So this unit rate is going to be really important for us. That one, you're going to see that word a lot. That's the title of the whole second focus area. So if we're asking how many people will 10 cups of rice serve, we knew that in the table. We got that as 30 people. Let's make sure we put a unit on there so we know it's not just 30 pieces of rice or 30 classrooms or something. How many cups of rice are needed to serve 45 people? And this was the answer right here, that we had 15 cups of rice. So those are just ones that go along with the table answers we got. All right, so we got a unit rate here. What I'm going to ask you to think about in the next one is, can we find a unit rate for the next one too? How many of something per something are there? So in this one, a recipe says 6 spring rolls will serve 3 people. Complete the table. So this time, to get from 6 to 3, what is our relationship going to be? How are we getting from this to this? And we know last time it was a multiplication relationship. So I'm going to challenge you to look for a multiplication relationship too. Was anybody thinking division? Maybe were you doing 6 divided by something gets you 3? Could we say divided by 2? If 6 spring rolls serve 3 people, right? 6 divided by 2 is 3. So 30 divided by 2 right here would be 15 people. 40 divided by 2 would be 20 people. And we know however many spring rolls we have divided by 2 is going to be the number of people we can feed. So can we work backwards? What divided by 2 is going to give us 28? It's a bigger number. 56 divided by 2 gives us 28. I'm going to challenge you to think, can we think of this as not dividing by something? Because dividing won't actually give us a unit rate. I still want to figure out, what are we multiplying by? If we're dividing by 2, what is dividing by 2 the same thing as multiplying by? Does anybody know this one? Dividing by 2 is like taking a half of something. Dividing by 2, you take a half. So you're really multiplying by a half. You're multiplying by a half. Dividing by 2 and multiplying by half, the same thing. 6 times a half is 3. So this right here, that half is our unit rate. Whatever we multiply by becomes our unit rate. And this is telling us how many people per spring roll right here. So you can get people per roll, I'll say. We can get a half of a person for each spring roll, which is kind of a weird thought, a half of a person. So what it really means is that it doesn't fill up a person right there. So it's saying that each person really is going to need 2 spring rolls to feel full for this. But this is our unit rate right there. So what we're looking for in all of these relationships is finding out what we're multiplying this number by to get this one, and that's going to be a unit rate that tells us how many something per something. So this one's a little harder. I'm interested to see what you guys have for this. Can you write a relationship between cups of rice and number of people in number 1 up here? So I'm going back up to the top, cups of rice and number of people in number 1. And we're going to include variables and an equal sign. So variables are going to stand for the things that we don't know. We're going to have an equal sign in there. So let me go back to cups of rice and remind ourselves what our unit rate was here. We had 2 cups of rice times 3 gave us 6 people. So in general, however many cups of rice we had times 3 gave us the number of people that we could feed, right? So if we're trying to get the number of people, here's how we can write an equation for that, a relationship for it. We want to get the people, the number of people. I'm going to call that P. However many number of people I need to feed, that's going to equal, what is our multiplication problem right here? We'd have to have cups of rice times 3. However many cups of rice we have times 3. So when we write that out, I could say cups times 3. I'm going to do cups of rice, or we could use R for rice if you wanted to, times 3. Another way we can write this is whenever you have a variable and a number right next to each other, you don't have to put that multiplication sign in between them if you put the number in front of the variable. So I'm going to rewrite this as the people we feed is, instead of cups times 3, I'm going to write 3 times the cups, and I don't have to put that multiplication sign in there. It means the exact same thing. So this describes the relationship. The people equals 3 times the number of cups, right? Could we do the same thing, even though it doesn't say on here, for this one, for number 2? What is my relationship here? How do I get my number of people? Where did this come from? This came from this number times what? We're always going to do the multiplication, times a half. So the people came from the number of spring rolls times a half. So should I say R for rolls or S for spring rolls? We'll say S for spring rolls. Spring rolls times 1/2. Or we can say, if we want to flip these around, 1/2 times spring rolls times S. So we're starting to look at how we write equations on these relationships that have unit rates, where there's something that we're multiplying between those columns. All right, if you've got this, let's flip over to page 2. Page 2 is pretty similar. This one now, though, has maybe some more difficult numbers that we're looking at. This one's called making bread dough. So let's read this one together. A bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. Ooh, honey and bread. Some days they bake bigger batches and some days they bake smaller batches, but they always use the same ratio, the same relationship of honey to flour. Complete the table as you answer the questions and be prepared to explain your reasoning. So again, I'm going to have you guys put pencils down. I'm going to have you try and brainstorm right now. Look at the questions that they're asking down here, basically just figuring out how we're filling in this information in the table. Can you use what we just did on the last page to try and help you figure out how you're going to get from honey to flour in this way? So I'm going to have you brainstorm for 1 more minute, but this time you're going to use not your shoulder partner that you just talked to. You're going to use what we call your face partner, the person face to face right across from you. So we're going to take 1 minute, no writing. You guys are going to talk about strategies that you can use to do this and talk about maybe writing an equation. How might you do that? And then we'll come back and actually try it. So 1 minute, talk, go. All right. Now that you've talked this through, go ahead and pick up your pencil. And you can go ahead and try this. Let's set a maybe 3-minute timer and let's see how much you can get done in 3 minutes. Go. All right. So let's look at what you might have found out. All right. Taking a look at this, we know last time we were trying to find our unit rate. I'm just going to kind of put a little column right here. We know that last time there was something that we could multiply all of these by to get the new one. We took this one, we could multiply it by something to get this. So the question is, 8 to 10, that's a little bit of a harder number to try and figure out. It can't be 8 times 1, it can't be 8 times 2, so it's got to be something smaller than that. So can we work backwards here and say, well, what's 10 divided by 8? What would that number be? And here's what I would look at. 10 divided by 8 is going to be my ratio. This divided by this is going to give me whatever my unit rate is. Do you guys remember how to do long division? Let's see. 10 divided by 8. Could put that inside. How many times does 8 go into 10? It goes in once. With how many left over? Well, it is 8. 8 times 1 is 8. We subtract. And 10 minus 8 is 2. So now to move on here, to actually say we need to add another 0, we'd have to put a decimal place here. It's just 10.0. That's the same as 10. And that lets us bring a 0 down here to continue the long division. Does anybody remember this? So then I also have to put a decimal point at the top. How many times does 8 go into 20 now? It goes in 2 times. 2 times 8 is 16. And what do I have left? 4. Bring down another 0. 40. How many times does 8 go into 40? 5 times exactly. So if I hit exactly, I'm done. So that means that what I'm getting when I do 10 divided by 8 is 1.25. So 8 times 1.25 is going to be 10. All I did was try to figure out what was this divided by this, because now 8 times this should be 10. There's our unit rate. Now you might have had other ways to go about doing that, but whichever way you did it, can you see that this unit rate is going to be something that you can multiply by? Right? So if we multiply this by 1.25 and multiply this by 1.25, times, not there, 1.25, we are going to be able to figure out the rest of this table. Okay, for this, there are parts of this unit that you absolutely can use calculators for. If we're working with decimals, I would expect you to be able to multiply this as a decimal. Right now, for the sake of time, just to check what we've got, I'm going to go ahead and multiply it on the calculator. 20 times 1.25 gives us 25. So if we're making some spread with 20 tablespoons of honey, we're going to be using 25 cups of flour. What about 13 times 1.25? 13 times 1.25, that's going to give us 16.25, not as big of a loaf there. Now this last guy, something times 1.25 equals 20. Can I work backwards? 20 divided by 1.25 is going to give me this. 20 divided by 1.25, 16. That's starting with 16 tablespoons of honey. All right, so essentially we've just answered number 1, 2, and 3 when we did the work in the table. So this one, 20 tablespoons was 25 cups. This one was 16.25 cups. What's 0.25 in terms of cups? If you were actually measuring out flour, we don't use 0.25, we'd use a fraction. That's going to be a quarter. 16 and a quarter cups, fourth of a cup. And then honey, which one was 16 tablespoons of honey. That's the abbreviation for tablespoon, TBSP, or you could use a capital T. Any of you bakers out there, capital T is tablespoons. So, last one here, what is the relationship, and this is a new word, proportional relationship, represented by this table? This is the same question I was asking on the last page that's talking about this writing a relationship here. So if we can use some variables and see what are we multiplying these two things by, what are we trying to find out here in this table? What was our kind of end result? If we knew how much honey, we could get the flour. So how do we get the flour? The flour is the honey times 1.25. Right? Honey times 1.25 gives us flour. So if I write that out, the flour, I'll use F, we said was 1.25 1.25 times the honey? Something like that. Do I have to put the dot in there? No, not if the number comes first. I can just write it like this, 1.25H. There we go. So this proportional relationship, what that really means is that there is a unit rate for it. Every time we can multiply by the same number, and it's going to give us the same ratio of ingredients in here. It's going to give us the same relationship every single time. So if you've got a unit rate, it's called a proportional relationship right here. And I'm going to go back to that unit rate one more time. We know that's what we were multiplying by, but in terms of what it makes sense for here, the unit rate tells us how many cups of flour per tablespoon of honey. How many of this for every one of these? That's why that's that unit rate. All right, so we've got page number 2 done. Good job, guys. So I'm going to have you flip over to page number 3. This is one now. We're revisiting these questions here. We're going back to recipe says that 2 cups of dry rice will serve 6 people. You're going to complete the table as you answer these questions, and there's a little bit more detail. So I'm going to have you try this on your own right now. We're going to say about 10 minutes, and I want to give you 10 minutes to see how many of these on page 3 you can answer. Read these new questions really carefully and see if you can answer any of the things on there, even if we haven't talked about them yet. And we'll stop the clock in 10 minutes and then go through the answers to this one. Go. Okay, so let's go through the answers that you guys got for this one. The cups of dry rice, and if you weren't sure how to do this, you're doing it with me right now. Get those pencils out, put in anything that you don't have, you're going to add in there right now. To get from 2 to 6, that was the only number we had. What would we multiply by? What's our unit rate going to be here? We're going to multiply by 3. All right, so that means in all of these, to get from the dry rice to the number of people, we're going to multiply by 3. So the first one, 1 times 3 is 3. Great, we did 2. 3 times 3 was 9. 12 times 3 is going to give us 36. 43 times 3, that takes me a little more thinking. Let's see. Okay, 40 times 3 is 120, and 3 times 3 is 9, so 129. All right, and what is this, x? That's if we don't know how much rice we have, how many people could we feed? Well, it's whatever rice we have times 3. So x times 3 is going to be our answer. We can feed x times 3 people. So I can either write x times 3, or I can write 3 times x, 3x. All right, so that's a new thing, having a variable in there. So how many people will 1 cup of rice serve? We answered that here. It's going to be 3. Now, that one, guys, it says it equals our unit rate. Isn't our unit rate 3? Our unit rate is the people per cup of rice. 3. That's our unit rate. It's got another name right here. Constant of proportionality. We have not talked about that yet. It is another fancy name for the unit rate. It is the constant, this number that stays the same that we multiply by every time when we have a proportional relationship right like this. So unit rate and constant of proportionality here, exactly the same thing. You'll hear both of those terms, so we need to know that as vocabulary. All right, how many people will 3 cups of rice serve? We said that that was going to be 9. What was 12? 36. 43 was 129 people. Okay. And then how many people will X cups of rice serve? We said that would be 3x. We don't know how many people it is because we don't know how much rice we have, but we know it's going to be 3 times as much rice we have. So can we write our equation for this? All right, I'm going to have you do something different. We are going to call this, instead of rice and people over here, we're going to call this x, and this one y. These are going to be our 2 variables that we've got going on. And we already had an x here, right? So x cups of dry rice will give us how many people? We're going to call that y. So the number of people we get when we're writing the equation, the number of people, we're going to call it y instead of p here. The number of people is 3 times however many cups of rice we had. 3 times the cups of rice is x. And the reason I'm switching to x and y right now instead of maybe r and p is because we're going to start looking at this on graphs. And graphs, the coordinate plane that you guys have used in the past, are based on x's and y's. So this right here is a pretty standard equation or relationship for a proportional relationship. And we're going to be able to see what that looks like on a graph. This was 3 times this. That's where we got it from. All right, we're going to do the same thing down here. This was our spring roll problem, and we had said for spring rolls that our unit rate was, we were multiplying, it's always what we're multiplying by, we were multiplying by a half, right? Multiplying by a half. So all of these are going to be times a half. Fabulous. So 1 times a half, well, that's just going to be a half. That is our unit rate. We get half of a person for 1 spring roll. 1 spring roll isn't going to feed a person. You need 2, apparently. These are small spring rolls. All right, 10 times a half. What's half of 10? 5. Half of 16? 8. Half of 25 would be 12 and a half. It's funny to have a half a person there. And if we had n, we're going to call this one n, the number of spring rolls here. N spring rolls, we don't know how many, but whatever it is, it's going to be times a half right here. So I'm going to say either n times a half or half times n. That's how many we'd get. So answering these questions, we just got them from the table already. This should be quick. That's going to be a half. 10 spring rolls, let's see, was 5 people. 16 was 8. 25 was 12 and a half. How many did n people serve? Half of however many spring rolls are there. Half times n. So can we write an equation for this one? And bear with me, can we just call this x again and y? How do we get our y, our number of people? The number of people we can feed, y equals, comes from however many spring rolls we had times the unit rate. So can I say 1/2 times the number of spring rolls, x, however many is in that column. So how was completing this table different from the previous table? How was it the same? Well, here we were multiplying by a fraction, but weren't we still multiplying by a unit rate to get there? So we're still multiplying. We've got to find what we can multiply by to get there. This one had some fractions in it. It was a little bit different that way. What about the equations here? How are these similar or different? Where's my equation up here in D? Both of the D problems. Do you see how they have the exact same structure? Y equals whatever that unit rate is, and then x. So that is a proportional relationship, and we're just starting to learn about those. Okay, we are going to look at the next page. This one, page 4 and 5, are the last ones that we are going to do. And we're still going to look at proportional relationships with this, but this one I'm going to do with you all together. So this one has to do not with food, taking a break from food, but this one is centimeters and millimeters. So it says there is a proportional relationship between any length measured in centimeters and the same length measured in millimeters, meaning the relationship between centimeters and millimeters is always the same. It never changes. It's not like one day a centimeter is going to be this long and the next day a centimeter is going to be this long. The relationship is always the same. So if we look at it, there's 2 ways to think about this proportional relationship. If you know the length of something in centimeters, you can find out how many millimeters it is pretty quickly. Let's take a look at that relationship first. If something is 9 centimeters long, how many millimeters is it going to be? Is it going to be more or less? If you've got 9 centimeters somewhere over here, it's going to be a lot of millimeters, right? How many millimeters are there in a centimeter? There's 10. So to get from centimeters to millimeters, it's going to be bigger. We're going to be multiplying by 10. So 10 is going to be our, what is this thing called here? Our unit rate. Does anybody remember the longer word we used to describe that? Unit rate, or the constant of, here's the word, constant of proportionality. So in this case, that's going to be 10. So to get from centimeters to millimeters, all we're doing is multiplying by 10. And we don't even need a calculator to do that. To multiply by 10, you just add a 0. This becomes 90 millimeters. If we're measuring it, that seems right to me. For this one, actually to multiply by 10 here, we're just going to move the decimal point over one place. 12.5 times 10, 125. 50 times 10, 500, yeah. 88.49 times 10, we're going to move the decimal point one place, and we get 884.9 millimeters. Ooh, that's a lot. So what was our constant of proportionality? What do we multiply by every time here? 10. That's our unit rate. There are 10 millimeters for every centimeter. How did we find this? Well, we kind of knew that relationship to start out, right? We knew that there were 10 millimeters in every centimeter. And can you write an equation to describe this relationship? All right, again, this first column is always going to be x. Second column is going to be y. So how do we get to our y? The y equals whatever x is times what? 10. It's our unit rate times the x. Y equals 10 times x. So what if I asked you, okay, we've got 10 centimeters for our x. What's 10 times 10? Then our y, our length, would be 100. Okay, let's look at this in the reverse way. What if we don't know the centimeters? What if we know the millimeters for this? So if we know the length of an object in millimeters, we can calculate its length in centimeters. This time, it's a little bit trickier because our unit rate, we know, is something that we have to multiply by. So I've got to figure out, what can I multiply this by to get to centimeters? Except that millimeters should be more than the number of centimeters, right? Really, in my head, what makes most sense to me is that I'm taking the millimeters and I'm going to be dividing by 10. That's what makes sense to me. So what could I be multiplying by then? Dividing by 10 is the same as multiplying by what? Do you guys know this trick? To divide by something, it's the same as multiplying by its reciprocal, the flipped version of this. This is like 10 over 1. So if we flip it around, the reciprocal is 1/10. Dividing by 10 is like taking a tenth, multiplying by a tenth. So you can think about this in your head as dividing. We just need to know for a unit rate that we're really multiplying by a tenth. We're making it a tenth as big. So can we finish the table here? If we know we're always multiplying by a tenth, which is really like dividing by 10, 70 times a tenth of 70. 70 divided by 10, 7. 70 millimeters, 7 centimeters. And you guys knew this. The important thing that we're looking at is that there's this idea of a unit rate every time. What about 245 divided by 10? We're just going to move the decimal point over 1 this time. 24.5 centimeters. Ooh, 4 divided by 10. What is that one going to be? That one's going to be way smaller. We're going to move the decimal place over one spot there. This is going to be 0.4 centimeters. Because 4 millimeters right here is definitely not even 1 whole centimeter, right? All right, what about 699.1? To divide by 10 or multiply by a tenth, we're making it 1 decimal point place over this way. 69.91 centimeters from 699 millimeters. So in this case, what is our unit rate or our constant of proportionality? It's what we're multiplying by. We're multiplying by 1/10. So how do we write our equation to describe this? Our first column is always x, our second column is always y, and are you getting the hang of this? Starting with y equals, this column equals this times what? Times our constant of proportionality. 1/10 times x, or 1/10 x. All right, you guys are doing great. We are almost there. Let's flip over. So question 3 just says, how are these two constants of proportionalities or unit rates related to each other? Let me remind you, the first one was 10 and the second one was 1/10. So how did I say those are related to each other? What are they called? They are reciprocals. Reciprocals. Have you used that word in the past? The reciprocal, the flip of each other? The other word for it that you might or might not know is this. It's a bigger word. I'm going to have you write it. Multiplicative, like multiplication, multiplicative inverses. Ooh, that's big words. Multiplicative inverses. Reciprocals and multiplicative inverses, wow, I can't even say it now, are the exact same thing. This multiplicative inverses references the fact that if you multiply 10 times a tenth, you multiply them by each other, you always get 1. So that's just another name for it. All right, can we complete each of these sentences? So I'm going to go back here just for a second. This is a vocab word. You do need to know what reciprocal is or multiplicative inverse. Know those words. To convert from centimeters to millimeters, what did we multiply by when we went from centimeters to millimeters? There would be more millimeters, so you're multiplying by 10. To convert from millimeters to centimeters, you can divide by, we divided by 10, which was the same as multiplying by 1/10. All right, you guys did a great job. There is an extra couple questions on here that says, are you ready for more? I'm going to skip that for right now, and I'll do those with you when I get back. You're welcome to look at it and see if you can come up with an answer to it, though, before we talk about it, if you would like to. It is not an assignment for you. So at this point, if there is any time left, you guys can do PLT. You guys will need to go to Mrs. Muchler to approve any first-time tests. It's possible that she might have enough time to look at approving math retakes for you because she was a math teacher last year too, so she does know the math curriculum. But I can't guarantee that if you haven't had a retake slip approved that she can do that for you right now. She will be able to approve first-time tests. So make sure that you are doing some great learning in your notebooks. You're writing down everything as you do it in math, and you'll be able to tell me next time when I see you how much you've learned today. All right, have a good time.